Hello, in this video we will review solving simultaneous linear equations, and this is for learning intention number 45. So these sorts of things crop up on exams. They're very sneaky. They'll often pop up not as a question, so it won't be like question 1, solve these equations, but it'll pop up as part of a question often. So it won't say explicitly that you need to solve linear equations, but it might say solve for the variance here, and you'll happen to need to solve a pair of simultaneous linear equations. So it's very important that you're confident with these. Now your CAS can do this for you, and the reason I've got 3 examples here is I'm going to show you 3 different ways that you can use your CAS to solve these as well. So I'm going to do each one by hand, and then we're going to look at a CAS method to solve each one. So let's start with example 1, and I'm going to be the height of perfect setting out. I'm going to do this exactly how you should set this out. First things first, you write your 2 equations like this, and then you have to label each equation. This is equation 1, ... this is equation 2. So we've got equation 1 and equation 2. There's a couple ways to do this. You can do substitution or elimination. Elimination looks like the best way. So I can see they've both got a positive b here. So I'm going to take equation 2 and subtract equation 1. Now let's see what that looks like. So we've got 2a minus a, which leaves us with a. b minus b leaves us with nothing. Negative 6 minus negative 12, so watch out, it's negative 6 minus negative 12 is going to be plus 6, and 0 minus 0 is 0. So then we get a equals negative 6. Now you have to say something like this: sub a equals negative 6 into, and you can choose an equation here. It's up to you. You can do 1 or 2. It's going to work out the same. It'll give you the same answer. Let's do 1 because it looks easier. Sub a equals 6 into equation 1. So we get negative 6 plus b minus 12 equals 0. Negative 6 minus 12. Watch out there because it looks like negative 6 plus 12. It's negative 6 minus 12 is negative 18 plus b, which equals 0, and b equals 18. Alright, let's write our answer nice and neat. So a equals negative 6 and b equals 18. That's all well and good, but I promised you a CAS method. So the first CAS method I'm going to show you for something like this is to use matrices. So you can actually do this with matrices. I'll show you the matrix method. What you need to do is get it into this form first. So we go a plus b equals 12. So we get each variable on one side and the constant on the other side. So that means it's going to be 2a plus b equals 6. And then we write it as a matrix equation. This is actually a 2 by 2 matrix. So the coefficient there is 1. We rip off the coefficients. The coefficient there is 2. The coefficient there is 1. The coefficient there is 1. We list our variables in a column vector or a column matrix, and we list our answers in a column matrix as well. So you can see this matrix takes on the coefficients, this matrix takes on the variables, this matrix takes on the answers, which means that AB is the inverse of this matrix. Remember, to get it over there we use the inverse times 12 on 6. So let's use our CAS to get the answer. Let's use our matrix method here. So if I'm right, this should give a column matrix with 6 and 18. So let's check it out. Calculate. Now we need to get some matrices here, so let's pop over to this 2 by 2 matrix, fill it out. We've got 1, 1, 2, 1, and that's to the power of -1 because it's an inverse, and that's times column matrix or column vector 12, 6. There we have it. We get -6, 18. So we can see that A, B equals -6, 18. And that's how we get our answer there. Now you might be thinking, well, that was a lot of work to put that into the CAS. Why would I do that? It does give us some extra information. So later on, we'll go into why that's actually useful. In some circumstances, that will be the best way to go. So you need to be comfortable with that. Alright, that's example 1. Let's have a look at example 2. So I'm going to do the same thing. I used elimination the first time, so this time I'm going to use substitution just to mix things up a bit. So this is equation 1, this is equation 2. Now let's rearrange equation 1. So we have 5x plus 3y equals -6, and I'm going to make x the subject. I've chosen that x is going to be by itself. So 5x equals, we subtract 3y from both sides, and then we divide both sides by 5. So we get -6 on 5 minus 3 on 5y. And we call that equation 3. We give it a name because it's a new equation. Now here's where you need to be careful. You can't sub this back into number 1 because it's the same equation, and you're going to get some nonsense like 0 equals 0 or x equals x or something like that. So you can't sub this back into equation 1 because you already used equation 1 there. So we're going to sub equation 3 into 2. So we sub x for here. So let's see. So we get 6. And we're going to replace x with all of this. -6 on 5 minus 3 on 5y minus 2y equals 32. 6 times -6 is 36 on 5 minus 18 on 5y minus, well, 2 is the same as 10 on 5. Y equals 32. And we need to keep solving. So we keep plugging along. -36 on 5 minus 28 on 5y, because I've subtracted these, equals 32. Let's go up here. So I'm going to multiply everything by 5. So -36 minus 28y equals 160. Add 36 to both sides. -28y equals 196. Divide both sides by -28. Alright, now we need to simplify that. Well, they're both even, so we can half it. So half of 196, what's that going to give us? That's going to give us 98. So we get -98 on 14, and we can keep halving. -49 on 7. Now that looks familiar. That's got to be -7. Let's check that. Yep, that looks good. So y equals -7. So what do we do to solve for x? Now you can sub into here, which is quite nice. We've made an equation that already has x by itself, so we can say sub y equals -7 into equation 3. So that gives us x equals -6 on 5 minus 3/5 times -7, which is -6 on 5 plus 21 on 5, which is it's positive 15 on 5, which is 3. So this time I'm going to write my answer as a coordinate. So the coordinate of intersection is 3, comma, -7. There's your answer. Alright, so we did a matrix method before. This time, let's see what our CAS can do for us. Well, we can solve these two by using the solve function. So menu 3, 1, solve. And if you go over here to this icon, you grab the bracket thing. I'll just, it's not wanting to move. Let's try again. There's this bracket. Okay, it's being very stubborn. Let me reload it. Alright, so we need to solve. So menu 3, 1, solve, and we go here, and we get this curly brace, and you write each equation in each box. So 5x plus 3y equals -6, and then 6x minus 2y equals 32, and then you pop off to the right, put a comma, x, comma, y. So put in your variables. Let's check that. 3, -7. There we go, we've got the right answer. Beautiful. So we've looked at substitution and using our CAS and the solve function to solve our equation there. Let's have a look at example 3. Alright, same story. We write out our equations. And label them. Try to have a go at this one before you watch me do it. I think that's a pretty good rule. Let's rearrange equation 2. Let's use substitution. So I'm going to solve for m. So we get 3m minus 2n equals -1. I'm going to move the -2n over this side by adding 2n to both sides. And I'm going to divide both sides by 3. Okay, and that's a new equation, 3. Now I'm not going to sub that into equation 2, I'm going to sub it into equation 1. So sub 3 into 1, so we get 9, and our new value for m equals 3. Expand the brackets, we get -3 plus 6n minus 7n equals 3. You can add 3 to both sides, so you get -n equals 6, n equals -6. Okay, so we need to solve for m now, so we can sub n into 3. Let's do that over here. So m equals a -3rd plus 2/3 times -6, which is -1/3 minus 12/3, which is -13 on 3. So our answer is n equals -6 and m equals -13 on 3. Alright, Another way to check this on your CAS. This is my favorite method. No curly braces, but using the solve function. Alright, this method uses logic. Your CAS can actually do logic. What I mean by logic is, if you go 1 equals 1, it'll say true, because 1 equals 1. If you go 1 equals 2, it'll say false. Another thing it can do is it can use something called the AND function. So it's to do with logic, if you're wondering where it comes from. But I'm going to show you how to use it. What you do is you go to solve, and you write your two equations. So you write 9m minus 7n equals 3. So that's one equation, space, and you just type and then the other equation, 3m minus 2n equals -1. And then you can put in your variables, which are m and n. So what this is telling the calculator is solve for this and this. So it's telling it you have to solve, but you have to make sure both work. That's what the AND does. And you can see right there we get the answer. N equals -6, m equals -13 on 3. The thing I like about the AND is you could use it for as many equations as you like. If you had 4 equations and 4 unknowns, you can use the AND quite easily. So that's a good one to keep up your sleeve there. So let's do a quick recap of the CAS functions that we've learned. So the first one was the matrix form. The second one was solve with the curly brace, equation 1, equation 2, variable 1, variable 2. The third one was solve except with AND. And I'll write AND as it is with AND. So make sure you can do all of these. And of course it's not x, y, it's whatever variable you're using. So in fact I'm going to be even more fussy with that, just to make sure we're clear. That's variable 1 and that's variable 2. And with solve, with the AND, we get equation 1 and equation 2, variable 1, variable 2. So you've seen examples of these 3. I hope you got something new out of that, and I hope a bit of it was revision as well. And if you have been, thanks for watching.